The video we are going to do an experimental analysis of Ohm's law. So basically, if you could remember, in the previous session we just saw the definition of Ohm's law, and it was stating that my voltage across the conductor was directly proportional to the current flowing through that particular conductor, right? So this is what we saw in the previous session, and in this session we are just going to prove that, right? We are just going to see if this condition is true or not. Okay, but before directly jumping onto that particular part, let me just give you one more concept, that whenever you connect a battery in series, I mean 2 or 3 different batteries in series, the overall voltage increases. So let's assume this is battery 1, okay, battery B1, and this is a setup wherein I have connected battery B1 with battery B2. So you should just see how exactly I have connected. Okay, so you see the negative terminal of battery B1 is connected to the positive terminal of battery B2. Okay, so whenever you will see this kind of arrangement, so that means what? That means these two batteries, they are connected in series. Just remember these two particular points, okay? And whenever you connect battery in series, the overall voltage increases. So let's say if this particular battery, let's say if battery B1 is of, let's say 5 volts. Okay, so over here as well, let's say B1 is 5 volts. Let's say B2 is, let's say 2 volts, right? So 5 plus 2, 7. So across this particular terminal you will get 7 volts. So this overall battery, they combine together and they will provide you 7 volts. Okay, I hope you are able to understand this. On contrary, let's say if the voltage of this particular battery, one sec, is let's say 1 volt. Okay, 1 volt. So now this setup, that means from here and here, if you place voltmeter across it, so you will get 6 volts over here. Okay, so you see the voltage increases as as the battery voltage B2 increases or decreases, right? I mean not decreases but increases, right? B2 was 1 volt, 2 volt, 3 volts, right? So as B2 increases, the overall voltage across this two terminals will also increase. I hope you are able to understand this. Okay, so for your understanding purpose, I'll just give you this value 5 and 2, so they add up and you will get value as 7 volts over here. Okay, so this is what it means. Just remember this particular point: if batteries are connected in series, overall voltage increases. That's it. Okay, great. Now we can easily jump forward to do certain experimental analysis. Okay, so you see over here, I'll be dealing with this kind of circuit, and I believe that now you are quite comfortable with this kind of circuit. So you see over here, this is my battery. Okay, so what does this sign mean? This means I'll be changing the voltage constantly. Okay, I'll be detecting the current whenever I'll be changing the voltage, the supply voltage. So basically this is my supply voltage and this is the voltmeter through which I'm going to detect the voltage across the conductor. So what we are doing over here is that, see, we have connected this particular supply voltage to this particular setup. I hope you guys know this particular setup. It is pretty simple. We have seen this kind of setup wherein we are connecting the ammeter to this particular conductor. Okay, so they both are in series. So let me just show the this signs, that is positive, negative. So this is the positive terminal of ammeter connected to the positive terminal of battery. The negative terminal of ammeter will be connected to the one side of the conductor. Okay, and obviously the voltage drop across conductor will be in this way, plus minus. Okay, so whatever the voltage that will be dropping across this particular conductor, it will be shown by this particular voltmeter. Okay, so let's assume the voltage drop, if the voltage drop across this particular conductor is V of X, so this V of X will be shown by the voltmeter. This is what we saw in the previous session as well, right? Whenever you want to check the voltage across any conductor, right? So this is what we saw. So what I'm going to do is that I'll increase the supply voltage. Okay, I'll check the current, and I'll also check the voltage across the conductor, and then we'll just try to deduce the relationship between this voltage and this particular current that we are detecting. I hope you are able to understand this. Okay, I hope you are able to understand this, because what was Ohm's law stating? It was stating that the voltage across the conductor is directly proportional to the current flowing through it. Okay, so basically we just need to monitor this particular voltage and this particular current and try to deduce certain relationship, certain relation in between both of them, right? And as far as we know that the relation will be kind of a straight line, right? Something like this. Okay, I hope you are able to recollect all of those points which we saw in the previous session. Okay, so by the way, this is my conductor. Let me just write over here. this is my conductor. As of now we are not clear what exactly is this particular conductor is. What we know is that it is a conductor. Basically its task is to transfer current through it, that's it. And whenever it will transfer the current through it, so obviously it is there will be some amount of drop across that particular conductor. This is what we know, that's it. Okay, so just remember this particular setup. We are going to design this same setup onto the Tinkercad software, and then we will try to just detect the values for the current and voltage across this particular conductor whenever we are just changing the supply voltage. Okay, so let me go on to the Tinkercad software. Alright, so as you can see, this is supply voltage. So we are going to change this particular supply voltage, right? So if you could remember, I have marked this particular voltage with the help of that particular arrow, indicating that we are going to change the voltage constantly. Okay, so that so this is that particular supply voltage. So you see the positive terminal of the supply voltage, it is connected to the positive terminal of ammeter, as you saw in the on the blackboard, right? Then you see the negative terminal of the ammeter, it is connected to one end of the conductor. Okay, so intentionally I have blurred this particular conductor. As of now I don't want to show you that what exactly it is. Okay, so just assume that over here I have connected one conductor. Okay, I'll reveal this particular material what exactly I have connected over here, so don't worry about that. Okay, just assume that over here I have connected one conductor, and across that particular conductor you see this is my voltmeter, which is detecting the voltage across that particular conductor. And you see the other end of the conductor, it is connected with the to the negative terminal of the battery. Okay, so I hope you understood this basic circuit. It's quite simple. So now what I'll do, as you can see over here, the voltage that is being supplied by this particular battery, it is 1.5 volts. So we'll just monitor the current and the voltage across this particular conductor, okay, at 1.5 volts. After that we are going to increase the voltage. That means this we are going to increase the supply voltage, and then we'll monitor the current that is flowing through the conductor and voltage across it. Okay, so don't worry, I'll explain you each and everything as we move further and further. So what I'll do as of now, I'll just run this particular simulation. Alright, so as you can see, when my battery voltage is 1.5 volts, so the current that is flowing through the conductor, it is 143 milliampere and voltage is 143 volts. Okay, so I request you to take a screenshot of it. This is very important, and in fact we are going to use in the further analysis as well. So it's my request that you please take a screenshot of it. So just remember as of now that at around 1.5 volts, which is my supply voltage, I'll just write it as Vs. So in that case I have the current as I as 143 milliampere. Okay, and the voltage across it, the voltage across the conductor is 1.43 volts. Just remember this. If you want, you can just take a screenshot of it. Okay, we are going to use it in further analysis as well. So I request you to please take a screenshot of it. Alright, I believe that you have taken a screenshot of it. So now I'll erase it and let's proceed further. Now what we are going to do, we are just going to increase the voltage, the supply voltage, right? From 1.5 volts we'll just increase it to 3 volts. Okay, so I'll just click over here and increase it to 2 batteries. Okay, so now I know most of you guys will ask me how exactly it became 3 volts. So if you could remember, I clearly mentioned you that if you see this kind of setup wherein batteries are connected in this way, so the negative terminal of the battery 1, okay, let's assume this is my battery 1, it is connected to the positive terminal of battery 2, right? So in that case what we say, this both batteries, they are connected in series and the voltage across them will be addition of B1 and B2, right? So now you see B1 is 1.5 volt, B2 is 1.5 volt, so total they will give output as 3 volts. So the output from this particular battery is 3 volts, right? Okay, and in fact I hope that you have seen this kind of setup in your remote phones. Whenever you have seen, if you have seen the cells in the remote phones, they are arranged in this particular way only. So basically this is a kind of series connection, right? I hope you all guys, if at all you have seen this kind of connection. Oh, okay, so it's a kind of series connection of battery. I hope you might have seen this kind of connection. Okay, so right now we are getting 3 volts from the supply voltage. So let me just run it and let me check the current through the conductor and voltage across the conductor. Alright, so when my supply voltage V of S is, let's say, 3 volts, at that time the current is 273 milliampere and voltage is 2.73 volts. Again, it's my request to you that you please take a screenshot of it. It will be very, very helpful for us in the further analysis. Alright, I believe that you all guys have taken a screenshot of it. So again, I'll erase it. And now I'll stop the simulation, and again I'll just increase the voltage. Let's say from 3 volts I'll jump to 4.5 volts. That means I'll just increase the number of number of batteries. Okay, so again, same logic. In the previous scenarios we had 2 batteries in series. Now we have this kind of 3 batteries in series, and all of the batteries, they are of 1.5 volts. So 1.5, 1.5 and 1.5. So you can add them up, you will get 4.5, right? Or in general you can write it as 1.5 into 3. So 15 3s are 45. So that will be 4.5 volts. Okay, so you'll be getting 4.5 volts from this particular battery. Okay, so let me erase this, and now let me start a simulation. Okay, so now again let me just write the value that we are getting over here. So when my when my supply voltage is, let's say, 4.5 volts, let me just erase it. Let me write it properly so that it will be properly visible for you. Yeah, when my supply voltage is 4.5 volts, okay, so in that scenario I'm getting the current as 391 milliampere and voltage across the conductor as 391 volts, sorry, 3.91 volts, my bad, 3.91 volts. Okay, so if you want, you can just take a screenshot of it. Alright, I believe that you all guys have taken a screenshot of it. So let me erase it, and once again we are just going to increase the supply voltage. That is, from 3 we are going to take 4 batteries. So 15 4s is 60, right? So from here we'll get 6 volts. Okay, from the battery we'll get 6 volts. Okay, so let me run this particular simulation, and yeah, you see, when my supply voltage V of S is 6 volts, so in that scenario I'm getting current which is flowing through the conductor as 500 milliampere and the voltage across the conductor as 5 volts. Okay, voltage across the conductor as 5 volts. So again, my humble request to you that you please take a screenshot of it. Alright, I believe that you have taken a screenshot of this thing as well. So by this we have completed the experimental analysis onto the Tinkercad software. Now we just need to fit the data onto our blackboard which we have captured. So I'll just stop the simulation and I'll just go on to the blackboard. Now we just need to see what kind of a graph we can obtain, since we have plotted the we have extracted the values for the current and the voltage across the conductor. Okay, so let me go on to the blackboard, and now let me just fit the values which you got. So if you could remember, the first value which we got for voltage, it was 1.43 volts. 1.43 volts. Let me write it properly. 1.43 volts, and at that time the current flowing through that particular conductor, it was 143 milliampere, right? 143 milliampere. Okay, then what we saw was the like when we increase the supply voltage, so in that case the voltage which we got across the conductor, it was 2.73 volts, and the current flowing through that particular conductor at that particular moment was 273 milliampere, right? After that, when we again increase the supply voltage, so in that scenario we got the voltage voltage across that particular conductor as 3.91 volts, right? And current as 391 milliamperes, right? After that, when we again increase the supply voltage. So at that time we got the voltage across conductor as 5 volts and current as 500 milliamperes, right? So this is what we found out. These are the certain values for the voltages across the conductor and current flowing through that particular conductor when we increase this particular supply voltage. So these are the values which we got. Again, I clearly mentioned that as of now I have not revealed what that particular conductor is, okay, but these are the certain values which we got. Now what we are going to do, we are just going to plot this particular values onto the graph and we'll check if we are able to obtain kind of a straight line graph or not. Okay, just make sure that what will be the value for current when my voltage is 0 volt. So let's assume my voltage is 0. So what will be the value for current? Obviously it should be 0, right? Okay, obviously it should be 0. Okay, it should be 0. So let me move further and we will just plot the values. So at around 1.43 I have current as 143 milliamperes. Okay, so 1.43, so that will lie somewhere over here. I'll just mark the point. I'll just mark the point. So 1.43 somewhere over here, and I have current as 143, so that will be somewhere over here at this particular point, somewhere over here. Okay, I hope this point is properly visible to you. Okay, then we have 2.73 and 273, so we have 273 somewhere over here and 2.73 that might be somewhere over here, right? 2.73, it will be somewhere over here, and 273, yeah, fine. So this value will be somewhere over here. Okay, something like this. After that we have 3.91 and 391. So 391 and 3.91, that will be somewhere over here, right? So 3.91, yes, and 391 milliampere, yes. Okay, so you see this is current in milliamperes. By the way, I just forgot to explain that this is in milliamperes and this is voltage in volts. Okay, and then we have 5 and 500 milliamperes. So we have 5 over here exactly and 500 milliamperes, means somewhere over here at this particular point, sorry, at this particular point exactly, yeah, something like this. And as we discussed, when my voltage is 0, so do the current will be 0, right? So what I need to do, I just need to join those particular points and let me check if we are able to obtain a straight line passing through an origin or not. One sec, let me just increase the thickness of the line and let me just check if we are able to get or achieve what we want. Of course we are able to achieve that. So yeah, you see over here, as I clearly mentioned, we are able to obtain a straight line passing through an origin. So with this, what can we conclude? Let me just check if I can change the color, maybe blue, or maybe, yeah, orange looks fine. I'll just take it to orange. Okay, so yeah, you see over here, if you could remember when we studied Ohm's law at that time, what we discussed that my V is directly proportional to I. So to remove this proportionality sign, I'll just add some constant I times of, let's assume that this particular constant is 1. We don't know what this constant is, let's say it is 1. Okay, so when we put this C as 1, so we get V times of I. Okay, so it's like Y is equivalent to X. So what does that mean? A straight line passing through an origin, and this is what we are getting, right? Y is equal to X. So what does that mean? That means the Ohm's law is absolutely correct. Okay, that means as my voltage is increasing, my current is also increasing across that particular conductor. As of now, we really don't know what that particular conductor is. Okay, I really hope that you are able to understand this particular concept. Okay, and this is how we proved the Ohm's law. Now the next task that is remaining, and that is to find the slope. Now again, I know most of you guys ask me why we are actually interested in finding the slope. I'll explain you each and every point, okay, as we move further and further. Don't worry about that. Okay, so what will be the slope? So it's pretty simple, y2 minus y1 upon x2 minus x1. So for that you just need to assume any 2 points. You can assume these 2 points, sorry, You can assume these 2 points, you can assume these 2 points, you can assume these 2 points, any 2 points, right? Any 2 points. So what I'll do, I'll just assume maybe any random points, that will be fine. So let's say I'll assume maybe this point and this point and maybe this point, this one. So with this I can easily find out the slope. Okay, so I hope you all guys know the formula for slope. Slope is equivalent to y2 minus of y1 upon x2 minus of x1, right? So let me just write the formula for slope over here. We'll just try to solve that particular thing over here. So slope is equivalent to y2 minus of y1 upon x2 minus of x1. So what is y2, y1, x2, x1? So you see y2 is 5, right? And x2 is 500 milliampere. So y2 is 5 volts and x2 is 500 milliampere, right? What is y1 and x1? So y1 and x1. So y1 is 3, sorry, not 3, it is what, 2.73 if I'm not mistaken. Yeah, check that. Yeah, it is approximately 73. Yes, so that is 2.73. and x1 is what? x1 is I guess 273. Yeah, 273 milliamp.